The El Niño Southern Oscillation, or ENSO, is a cyclic change in winds and sea surface temperatures in the Pacific Ocean. The warmer phase, El Niño, and the cooler phase, La Niña, influence global climate. In this work, researchers set out to determine what impact El Niño and La Niña have on hydroelectric power generation. To explore this question, the researchers generated time series of power production for more than 1,500 hydropower dams worldwide, representing more than 50% of the world's installed hydropower capacity. The results show that more than one-third of the dams had statistically significant changes in energy production during at least one of the two phases of ENSO. The researchers generated the time series of production data by developing individual models of each of the dams. The models included the dam's design specifications and gridded historical inflow data derived from a global hydrological model. Each model also uniquely simulated the behavior of the operators at each hydropower dam as an optimal control problem. The amount of water released was a function of the month of the year, the storage level, and the current inflow. Each dam was simulated using inflows from the year 1906 to 2000. The results were then compared against identified periods of El Niño and La Niña. As shown in this figure, the researchers found statistically significant increases or decreases in hydropower production at 34.7% of dams during El Niño and/or La Niña. Each circle is a dam, and those with black outlines show where the change was significant. This figure shows correlation between hydropower production and the extended multivariate ENSO index, a measure of the intensity of an ENSO event. 27.4% of reservoirs showed a statistically significant correlation with this measure. Production was most affected in the Northwest United States, South America, Central America, the Iberian Peninsula, Southeast Asia, and Southeast Australia. One interesting finding is that all of the increases in production tended to be cancelled out by all of the decreases when averaged across the globe. This was true for both ENSO phases. Another important finding was that many of the dams showed only a weak correlation between annual inflow of water and power generation, with a noticeable lag. This is a result of the dam's design specifications and operating rules. This finding means that in order to get an accurate picture of the impact on hydropower production, it is essential to model the design and operation of the hydropower dams themselves.